Hey.
I don't know if you had posted what we did.
You were in class.
I was gone.
Oh wait, you were the only one gone.
Yeah.
Okay.
Post the stuff on.
It was right after 4.5, the 4.5b in the packet. We just did more practice with factoring.
Perfect.
Thank you. Did I not? Okay. Tomorrow is early release, which means shorter class. So we need to go Zoom today. I want to make sure we get as much stuff in as possible. Chapter 7 is, I did it before 6 because this is stuff you have to know to move on to calculus. You will use it a little bit in trig, but you have to know this. Technically, everything we're doing is Algebra 2 standards. Technically, half of this class has been Algebra 2 standards. But, you know, we should eliminate Common Core because people don't know what that means. Who was gone last time? Okay. Right? This is two. Just the two potatoes. Oh, no, third one. Yeah, someone needs to remind me around 5 that I need to plug the calculators back in. Yeah.
5?
Yeah. End of game club.
Oh.
Because I forgot to last night.
I am hungry. You're supposed to make everyone else hungry, not the other way around.
What?
Should be relatively quick. Who's still going? Okay. In case something suspicious in store-bought muffin looks over at Logan. Sus. Good. All right. Write an equation in standard form for a parabola with this focus opens upward. As soon as I hear opens upward, I'm going to draw generic parabola opening upward with an axis of symmetry, a directrix, a vertex, and a focus. U. Tells me the focus is -1, 7. Opens upward, contains the point 7, 13, so that way, that way. What do I do with that? Distance formula, or Pythagorean. And you should recognize good old Pythagorean triples again. A 8, 6, 10 triangle is a 3, 4, 5 triangle, just bigger. I find that distance. What can I use that distance for?
To find direction.
Okay. By definition, that is the same as my distance back to the directrix. So what is 10 south of 713?
7, 3.
7, 3, which means my directrix is at y equals 3. Since my axis of symmetry goes through the point -1, 7 and it's a vertical line, I know my axis of symmetry is x equals -1. And the connection or intersection of those two, the point -1, 3, is itself not a feature of the parabola, but it helps me to find the one that is. Because halfway in between focus and that point is my vertex. Halfway between -1, 7 and -1, 3 is a vertex of -1, 5. It also tells me that I will go 2 units in both directions. It tells me how far I'm going to peek. How? Midpoint formula. 3 plus 7 is 10. 10 divided by 2 is 5. Or the distance between them is 4. Half of that is 2. So go 2 from either side. So, if I have a parabola opening upward, right away I know I have x minus thing squared is 4p by y minus thing. I just found my vertex is -1, 5, so I know my h and k. Because the focus and directrix are 2 units away from that vertex, I know p is 2, so 4p is 8. Oh, and if I want a extra point on there to show my stretch or compression, because it does say to graph. 1 over 4p is my a value for my stretch or compression. So it's a 1/8 compression. So I can go from that vertex over 1 up 1/8. over 2 up 4/8, over 3 up 9/8. I can keep doing that until I get something decent. Or how about, since I already know one integer value on my graph, that was to the right 8 and up 8, I could go left 8 and up 8 for its evil twin. Now that's just the one that I chose. Could you have done different? Yeah. I'm betting if you did anything, it was probably a perfect square divisible by 8. I'm betting you went over 4 and up 2, because 16 over 8. So maybe you had instead the point 37 or the point -57. So we're going to say step 1. Did you find the distance and use it correctly? Meaning you didn't just find 10, you used that 10 to go in the correct direction to find thing. Once you found thing, your focus and your axis of symmetry should be a gimme. If you found that correctly, then your directrix should be a gimme. Halfway in between them is your vertex. Did you put it all together for your equation? So you found your distance and used it appropriately. You have your axis of symmetry and your focus. You have your axis of symmetry and your directrix to get your vertex. There we go. Words are hard. Yeah.
I didn't put a point on the other side of parabola. Is that 1 point off? Because it had 713, I didn't put a point.
That was a given. So yeah, because you don't have the stretcher compression shown. Okay. We need that stretcher compression shown. Otherwise, it's just kind of a parabola. All right. I was only asked one question. It was that last one, 60-something. And y'all, if you have an X and a Y, a coordinate, you can always plug in what you know and solve for what you don't. And that's how that last one was done. You plug in H, you plug in K, you plug in X, you plug in Y, solve for the 4P value. But anything? I don't know if we're just checking out or if it's going really well.
I think this chapter's been really easy.
Because even my regulars have not been asking questions for a while. Like, we're good? All right. Then we left off of with our line of tangency problems. Remember that distance that we just found from there we go. Okay, if I have any contained point, this distance is the same as this distance. But it turns out it can also be used a different way. It can also be used to go back along my axis of symmetry to find this nameless wonder. Doesn't even got a name. It's just a thing. It's a point. But what's the relevance of that point? Okay. That line of tangency only occurs at a perfect spot with a perfect slope. Because otherwise, if I tilt this line just a little bit, if the slope tilts a little bit, if I move this up or down a little bit, that bullet graze turns into splat. And it ain't tangent anymore. Now it's secant. Now it goes through the parabola. We don't want that. Okay, this is leading into, I've been talking all semester about PreCalc has this dubious honor of trying to prepare you for 3 different classes simultaneously. In most schools, a lot of what we've done already, including this chapter right now, this is all Algebra 2. Or at least it used to be before parents conflated investigation-style mathematics with Common Core standards. Common Core standards means stop lowering the bar. Stop calling Algebra half Algebra 1. Algebra 1 is here. This is what Algebra 1 is. Stop doing only lines and calling it Algebra 1. Well, we are doing a lot of Algebra 2 stuff in PreCalc because our Algebra 2 isn't really Algebra 2, it's Algebra 1.6. This kind of stuff is laying the groundwork for calculus. You're supposed to be ready for trig and calc and stats leaving this class. So this, have you heard of a derivative?
Heard of it, don't know what it is.
Integrals. Okay. A derivative is if I have a curve, a derivative says I can't find the slope of this curve because the slope at this point, a tangent line, is different than the slope at this point because it has a different tangent line. So the slope of this thing is its derivative and it's an entire other function. Well, I can't do that if I don't know how to find a friggin' tangent line in the first place. So this is the foundation. Okay. All I got to do is find that distance, same as we did in our daily quiz, and I use it a different way. Before I start anything, I have to make sure that my parabola equation is in standard form. So, standard form, remember, x is squared, so it'll look like x minus h. The quantity squared is 4p by y minus k. So step 1, make that equation look like that. Literal equations. Chapter 2, Section 5, Algebra Half. Make this equation look like that. Inverse operations to move things around. Okay. Subtract 4, divide by 4. Now, what I don't want to do is divide both the y and the negative 4 by 4, because I'm supposed to leave it in the form where that 4p value is factored out. That's going to help me find my focus. Once I'm in the correct form, the graph. Where's my vertex? 0, 4, HK. Even though this doesn't have the x minus 0 quantity squared, because that's not the simplified form, I know that that 0 is there. So I've got a vertex at 0, 4. Cool. What's the focus of it?
Is it 0,
17.
negative 3 3/4?
0.65. Because this is my 4p value, which means divide both sides by 4, p is 1/16. I need to go north of this point. How do I know it's opening upward? X is squared, so it's vertical, positive 4p value. So I need to go 1/16 north of that point. 4 and 1/16, going all the way back to elementary school. Multiply, add, is 65/16. So barely off of that point.
That's a.
Okay. Means I have a focus at 0.65. Again, I want this in fraction town because it's going to help me later when I have to move a certain distance. Also, when I do square roots of things and have denominators, odds are these are arranged in such a way that it's going to come out as a perfect square. Okay, it says we contain the point -1, 8. So -1, 8. 1, 2, 3, 4. Oh, I should put you over here instead. I should put you over here. There we go. And I can mirror those points to make more of a graph. Remember, this is my axis of symmetry. My directrix is like barely off the line here. And if I go from my vertex left 1 up 4, then I can also go right 1 up 4 to make a skinny mini graph. Which should make sense. Remember that this is also 1 over a. So that means a is 4. It's a 4 times vertical stretch. Okay, so I got a parabola. It's ugly. Now what do I do? Tangent line. I got to find that distance. Seriously, that parabola just offends me. God, it's bad. It's still bad, but it's better. I need to find that magical distance there from that point back to my focus. And that's my distance formula. My distance formula says x2 minus x1. This point was -1, 8. There we go. x2 minus x1. 0 minus -1, the quantity squared. Some of you were missing your negatives yesterday. Be careful with parentheses. Plus the quantity, 65/16 minus 8, the quantity squared. Well, 8 in terms of 16 is 80, 48, 128, 65, -63/16. Right? 16/16, 63/16. Oh, but then you have to square it. God, that's gross. That's 3,600, 180, 180, 3969, 16, 3969/64. It's 1, 64 64ths is 1432 64ths. Nope, doing this. Poke buttons. Okay, poke buttons. I think I did it last hour, right? No? Oh yeah, I didn't save anything because Frank completely crapped out last hour. I type square root of stuff. Okay, 0 minus -1, 0 minus -1, parentheses squared plus the quantity 65 over. Screw you, Frank. Keep up.
You should try some positive incursion.
No. The beatings will stop when morale improves. Okay? Press the buttons. It should be 65/16 if I remember correctly. Okay. So the purpose of that is if this is 65/16, then that also means this is 65/16.
What is that?
What's 0 65/16 minus 65/16? 0, 0. I have found my magic point. Hopefully you remember how to make a line because you passed algebra half. The tangent line between those two. Can you make a line between those 2 points? God, I hope so. Count boxes. What's the slope? Down 8. What's the y-intercept? 0. Done. So the reason that these are going to be a little sketchy is sometimes you're going to have fractions. Sometimes the fractions are going to look ugly. They're going to look scary. But then it turns out they designed the problem in such a way that it'll come out clean. That is not always the case. It is entirely possible that I get this point right here is instead something like 0, 65 minus the square root of 39 over 16. It's entirely possible you get something like that. I'm pretty sure that doesn't happen in our assignments. I intentionally make the quiz test problems in a way that that won't happen. Okay? But if I had that, you could make a linear equation between those 2 points. It's just going to be disgusting. 5b comes out nice and clean. Like genuinely nice numbers. So, give it a whirl. You're finding the equation of that line. What is the bullet grays line? Frank couldn't keep up. I was pressing the buttons and Frank was like 3 buttons behind.
Y squared.
At the very least, you got to get your equation right. Subtract 5, multiply by -4. Don't distribute, leave it in the 4p spot. Now, where's your vertex? Which way does it open? What is P? Where's the focus?
Oh, also 5. So then that means the distance back here is 5.
The distance is equal to 5 is 0, 5.
Oh, I see. It's not very dumb.
It's not very good.
It's not very good.
I have problems with that class
Why?
because they say everything's so wrong.
Oh, yeah.
Like, basic early childhood psychology and neurodevelopment is nothing like they say in that class. That's how you get a bunch of autism moms who think they know what the hell they're talking about and putting on Facebook.
Y is equal to 1/2 x, and we need to find our y-intercept,
Oh.
which y-intercept
It's just say it's who building it, because I have all the pieces to make that. The book, the hand, and the eye, and that's all Sisay's going to do.
Well played. That is a noble pursuit.
Oh yeah, it would be like that. You're right.
Yeah.
Wait, can you show us? Okay.
Why?
We forgot. Oh, that way?
That way.
It seemed like it was some stuff. This let's go to the point one. It's off-road. No. You sure? Just T. We can move it over. I mean, you could do this.
I mean, neither. I don't know. Yeah.
Nice.
Okay, so on this one, it was.
Oh, 0, 5. I did the wrong coordinates.
So that's what
I swatted X and Y.
I can't see. don't really. I just. A is good.
Just your pushing to song the same.
Remember that 1 over the 4p value creates your A for stretch and compression. All I did was use that to make more points for my parabola. Your 4p value is -4 divided by 4. P is -1. So your focus is 1 to the left of that point because it opens to the left.
P is -1.
Yep. The other point that is contained that I was given, 1, -4, 1, 2, 3, 1, 2, 3. Are you getting here? Like this isn't even what they're asking for. This is just, can you graph it? Okay. Once you're there, the distance from here to here, you can either do Pythagorean or distance formula. That distance is going to be 5. So what do I do with that 5? Okay, there's 2 applications for that distance. Option 1 says it is now 5 back to the directrix. That ain't what we're doing. We're trying to find that magic point so we can get a line of tangency. So instead of having a distance of 5 back to the directrix, that was a terrible line. Instead, I'm going to use that distance back along my axis of symmetry to go find that magic point that'll help me get tangency 10, 0. 9, 0, because you go from the focus. It was closer. I looked at the wrong one. And then your line is just between those. So what's that? 8, 4, slope is 1/2, so boo. Can you make an equation of a line between those 2 points? God, I hope so. I did that a month and a half ago with my freshman. Slope is y2 minus y1 over x2 minus x1. Or count boxes since it's graphed out. 0 minus negative 4 is 4. 9 minus 1 is 8. 4 over 8 is a slope of 1/2. Now you can go real old school. Plug in a x, plug in a y, plug in a m, solve for b, put the pieces together. Or any textbook written in the last 20 years uses point slope form instead, because everything's in one spot. Then you just distribute and add over the y1 and you're good to go. You don't have to put pieces together at the end. So your choice. Running out of colors. Kind of blue. Which coordinate should you use? It literally doesn't matter. But if I'm given a choice, I'm going to pick the one with a 0 in it. Distribute and add 0 is 1/2 x minus 9/2. Okay. Step 1 is just graph the friggin' parabola. You have to be able to do that from yesterday. Step 2, find the distance. Step 3, go that far back along the axis of symmetry to find your magic point. Step 4, an equation of a line between any 2 points. Okay. It's got applications. You get up to calc, get into physics. But that's where we were supposed to end yesterday. This is where we're supposed to start today. Ellipses. Maybe in the old day you called it an oval. Okay. An ellipse is essentially 2 parabolas stacked end to end. Okay. I mean, think about that. A parabola, end to end. Okay. 2 parabolas end to end. So that means it's going to have a lot of similar features, just 2 of them. It's going to have 2 vertices. It's going to have not 1 focus, it's going to have 2 foci. Foci. It's fun to say. But in addition, now we're also going to have, instead of just my vertices, I'm going to have co-vertices, where those 2 parabolas met. They're going to be along what we're going to call a major and minor axis. Major axis is the big one. Minor axis is the little one. Pretty self-explanatory. And in the middle, where those things connect, is my center. So I'm not really worried about find the vertex and work from there. Now I'm going to say find the center and work from there. So, okay, it's a couple of parabolas smacked end to end, but what does it mean? What is its definition? How do I even get this thing? Okay, last hour confirmed. I'm not that old, they still have these. Do you remember a spirograph? A spirograph had this little sprocket with a hole right there. And you'd put your pencil in the hole, and as you went around the loop, the gear would turn your pencil. And it would keep making these cool designs. Okay, now I said in here we're doing an awful lot of Algebra 2 stuff. When I started this class and Algebra 2 was a little bit higher, we actually used to take a day off to do spirograph stuff, and then we would go find the equations for them and pretend that it was math, but instead we just colored for the day and it was fun. But we don't have time for that, so womp womp. Just like in Algebra 2 when we did our, what is it? We did parabolas and we did systems of equations and the effects of parabolas. We would go down to the gym and we'd have PVC marshmallow shooters. We'd shoot each other with marshmallows for the day, but then we'd gather data and make equations out of them. Yeah. Don't have time for it now. That's what this is. Just like a parabola is the locus of all points, such that, insert definition here. Distance from focus to point is point back to directrix. Well, this is kind of like that spirograph where think of here's a pin and a pin. I got a string in between those two pins. I pull it tight with my pencil, and then I start going around the loop. Well, that string length never changes. So what they're saying is that distance 1 plus distance 2, the total length of that string, is the same no matter what, including if my point is way over here. Now distance 3 plus distance 4 still equals the same thing as distance 1 plus distance 2. It's the set or locus of all points such that the sum of distances between the foci to the point are always the same. And that's why when I get right here, kind of in between the 2 points, it's not very far away from the major axis. But when I get real close to the pin, well, that's having to take this little distance and that big distance. That's why it narrows so much next to the foci. Now they have features that are very, very, very easy to find. First, I'm going to look at the equations. You know what, let's just look at one of them. Okay, the center of that thing. Super easy to find, just like my vertex. It's at HK. Bass-Ackwards land. A squared and B squared are going to determine where my vertices and covertices are, and they're very, very, very easy to find. If A squared is thing, square root of that gets me A. I'm going to A in this direction and A in that direction to find my vertices. B squared is other denominator. I square root that, I get little b. I'm going to B in that direction and B in that direction to find my covertices. Notice they're labeling them vertex 1, vertex 2, covertices 1, 2. Which one's which doesn't matter. It's just saying, hey, here's the 2 of them. So actually really easy to find that. Center. Go that far in those directions, go that far in those directions. Draw your potato. And I say draw your potato because let's be honest, if I said here's your center, here's your vertex, vertex, covertex, covertex, most of us, when we draw that, it kind of just looks like a potato. Or like Stewie's head. Okay. The part that's not in the problem is to find my foci. Remember, this is a set of all blah, 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 something, something distances. Distance formula, Pythagorean theorem. Those foci are going to be little c, which is nowhere in my equation. Little c is square root of a squared minus b squared, which should look awful familiar. Hypotenuse squared minus leg squared. That's how I find my foci. I'll C in that direction and C in that direction. And those foci might be written as compound numbers. Said, I get a little grumbly about You were supposed to be doing X, Y, and Z for the last 3 years. But your teachers let you work with decimals. Your teachers said, that's good enough. Your teachers did not force you to be accurate. So then you come up here and we get something like my center is at 2, 5, and I'm supposed to 3 square root of 6 in that direction. And I'll get kids all the way in PreCalc, even though this is an Algebra 1 standard, they don't know how to write that coordinate now. How do I write that coordinate? I have to leave it as a compound number. It's 2 plus 3 root of 6, 5. You should have been comfortable writing numbers like that for the last 3 classes. Well, now you have to. So, okay, I got an equation, HK, A, B, put center, A in those directions, B in those directions. Find C off to the side, I got my foci. Well then, what's the big deal between these two? Look at their formulas and look at which way the ellipses are stretched. B and A are swapped, and that meant it was stretched a different direction. Can we make a generalization about that? A is the important one. A is the important one. A squared is always the bigger denominator. Doesn't matter what order I wrote it in. It matters whether A squared is with the X term or the Y term. Because whoever has A squared, it's stretched along that axis. Vaxis, that axis. There we go. Meaning, no, go away. Go away. Since A squared was with the X term, it's stretched along the X axis. It's stretched horizontally. Since A squared was with the Y term, it's stretched vertically along the Y axis. Okay? So, here we go. Womp. Drawing these is actually super easy. So, stage 1. Where's my center? Okay, HK, bass backwards land. 3, -1. 3, -1. Okay, center at 3, -1. Okay. So I'll even do that. I'll kind of get some purple up there so we know that's where that came from. Will this thing be stretched vertically or horizontally, and how do I know? Horizontally, because the larger denominator, 36, is with the X term, so it'll stretch along the X axis. And square root of that, A is 6, it tells me I'm going to 6 in that direction and that direction. So I'll go 6 to the right of this. 1, 2, 3, 4, 5, 6. And that's my vertex, and it's at 9, -1. I'm going to 6 in that direction for a vertex of -3, -1. I will say B is 3, right? B squared is 9, so B is 3. So that's my minor axis. So I'm going to be in that direction for a co-vertex of 3 and 2. And I'm going to be in that direction for a co-vertex of 3, negative 4. I've got all my vertices. Draw your potato. No, not you. I want that color. There you go. Yeah. Yeah, it's a potato. Okay. And then off to the side, I'm going to say C is the square root of a squared minus b squared. 36 minus 9 is the square root of 27. Make sure you always simplify it. 3 root of 3. Go ahead, compare artwork. I've seen some pretty bad potatoes. Okay. So I know that the foci are going to have to be written with the compound number, but where do I put them on the graph? How do I know how far to go? Do you know what 3 root of 3 is off the top of your head as a decimal? Could you ballpark square root of 27 though? What perfect square is real close to 27? 25. What's square root of 25? This is bigger. 5 and some change. So go 1, 2, 3, 4, 5 and some change, and then label your focus is at 3 plus 3 root of 3, negative 1. Go 1, 2, 3, 4, 5 and some change. Label your focus as 3 minus 3 root of 3, negative 1. Ta-da! You have your ellipse. Now, someone's going to ask, what about that whole major-minor axis thing? It's used more in creating the, used more to create the equation, but the major axis is this line between those two vertices. Well, I 6 in that direction, then I 6 in that direction. I'd say my major axis is 12 units long. I 3 in that direction, 3 in that direction. I'll say my minor axis is 6 units long.
That's like a feature of the graph.
Yep, we're going to use that tomorrow to finish off here's features, write equation. I said day 1 is here's equation, make features and graph. Day 2 is here's features, make equation. Okay? And Darth Maul! The day is here. Complete the square twice in a problem or you have no idea what's going on. I told you it was coming. That's why I try to stress all the way into Algebra 2, don't give me that look, Zoe, that we have to do complete the square in addition to quadratic formula because here it is. I got to complete the square twice because I see 2 squared things. Step 1 would be to put those things together. All of your X stuff together. And now, because I've got 2 squared things, also all of my Y stuff together. And all of my not X or Y stuff to the other side. Meaning, subtract 24, put the constant over there. Okay? So, step 1 to complete the square was variables over here, constants over there. I did that, I just had to group things because it's happening more than once. Stage 2 was to divide everything by A. Well, I can't divide everything by 4 because if I do, I'll put a 1/4 here. Then I'll have to divide by a 1/4. That'll put a 4 here. Then I'll have to divide by 4, back and forth and back and forth. So instead, I factor it out. which is another skill we tried showing you all the way back in Algebra 1 to make vertex form of a parabola, which we reviewed again in Algebra 2, I say because half of you came out of my Algebra 2. Then, the magic number to complete the square. The idea of complete the square is I want to make this a perfect square trinomial. So I put b over 2 squared with both of them. B is currently -6. Half of that is -3. -3 squared is 9. Half of 4 is 2. 2 squared is 4. What you do to one side, you do to the other. If I added 4, I need to add 4. I did not add 9.
You added.
I added 36. You have to look at, even though I put the 9 in there, and that does complete the square, it's in parentheses with a 4 on the outside. I didn't really add 9. I added 36. Okay? So now, this is a perfect square trinomial. I can rewrite it as x minus 3, the quantity squared. If I don't know how to factor it exactly, it's always x plus b over 2, the quantity squared. 4 out front. Y plus b over 2, 2, the quantity squared, and 16. Whoa, whoa, we're almost there. Go back and look at your formulas. It was x stuff over denominator, y stuff over denominator equals, has to equal 1. In fact, that's how I get my denominators. So I need to divide everything up here by 16 and reduce where possible. This is x minus 3. The quantity squared, 4 over 16 reduces to 1/4. Plus y plus 2, the quantity squared. 1 over 16 is, well, 1 over 16. Divide all three terms by 16. Will this particular ellipse stretch vertically or horizontally, and how do I know?
Horizontally because the bigger values underneath the y.
Vertically, because it's under the y, because it stretches along the y-axis.
Oh, I just said
Okay, so I'm going to come over here and I'm going to draw a vertically stretched potato. That's good enough. I'm going to start labeling stuff on it. Now, you notice on the last one, okay, you should all have this on your actual graph, right? There. So if you've got all this, I'm going to come down here so I can actually have my graph. Oh, screw you, Frank. There we go. Better yet. There. Can actually see what's going on. Where's my center? Okay. 3, -2, womp. And I can, just off to the side, say my center is 3, -2. That's legal. Remember, just like with our trig graphs, there was a lot of us that started just putting all of our labels out to the side instead. Okay. Which one's a squared?
6.
So what is a? So I'm going to a in both directions. I'm going to a north 4 for a vertex at 3, 2. I'm going to 4 south of that to have vertex 2 is at 3, -6. B squared is 4. B is 2. So I'm going to 2 in both directions. I'm going to 2 this way for a co-vertex. I'm going to 2 in this direction for a co-vertex. 1, 2. Say my co-vertex 1 is 2 back from this at 1, -2. Co-vertex 2 is 2 to the right of that, so 5, -2. I now have enough information to draw my potato. What am I missing? Foci. I've got a pair of foci. And to do that, I'm going to find C is the square root of A squared minus B squared is the square root of 12 is 2 root of 3. So square root of 12 is about how much? Look at the perfect squares on either side of it. Okay, square root of 12, the perfect square below it is 9. The perfect square above it is 4. 3 point something. So just go 1, 2, 3 point something for my focus. Go 1, 2, 3 point something for my focus. And then down here, I'm actually going to cheat with this one since they're radicals. I'm going to say that my foci are at 3, -2 plus or minus 2 root of 3. Or you can label them separately.
So you can combine.
On that one I can because they're not going to simplify any further. I don't want to do that with my vertices. I don't want to say that my vertices are 3, -2 plus or minus 4 because that's something I could actually simplify. This can't be simplified, so I might as well just leave it like that. Okay? What do you like better? Label the stuff on the graph so the numbers are right there next to the point, or put the things in the right spot, label it off to the side? I take both. Okay? I take both. You do whatever you're going to do. So, step 1. Can you even... Boy, that's a... Can you even? Can you make this potato? Can you make this ellipse? Start with 1A before I have to complete the square. I like that. Is it a wide potato or a tall potato?
Oh, did you? I think you want to write the median along the axis.
You don't have to.
Oh, you don't.
I said those are usually used for creating the equation later. They'll say, this is a focus, or here's your 2 foci, and here's the length of the minor axis.
Oh, so
Go make the equation. Yep.
Yes.
I mean, like that last one, if I wanted to be real prim and proper about it, I would say the major axis is 8 units along the line x equals 3. But that's like the pedantic jerk who says, you know, can I go in the bathroom? I don't know, can you?
yeah.
Like that. It's not much. Yeah.
Yeah, as long as you got the points labeled and it kind of looks like an ellipse, we're all right. As long as it's not a diamond. Grins sheepishly. Where's the center?
6
Okay. I know it's stretched vertically because the larger denominator is with y, so it's stretched along the y-axis. If I know the a squared is 16, then a is 4. That tells me I will 4 north and south to find my vertices. So I'll have vertex 1, 4 north of this is at 6, 1. Vertex 2, 4 south of that is at 6, negative 7. If b squared is 9, then b is 3. I'm going to 3 in both directions. 3 to the east, covertex at 9, negative 3. Covertex 3 to the west is at 3, negative 3. And off to the side, c is the square root of 16 minus 9, or square root of 7. So 2 point something-ish. This was 4, so I'm going to go 2 point something-ish, a little more than halfway there, and get a focus of square root of 7 north of this is just 6, negative 3 plus root of 7. Is just 6, negative 3 minus root of 7. Okay? And in fact, if you draw it like that, if you label it as vertex 1, covertex 2, focus 1 and 2, if you label it that way, I'll tell you what, that makes me a lot more likely to respond in a timely manner when you send me a screenshot of your work and say, is this right? Then I can say, focus 2 is off. Okay?
So I know that A is the bigger one, but if it doesn't give it, so like you just assume that the 16 is going to be A because it's bigger than that.
What do you mean since it doesn't give?
Well, because A is bigger than B.
Yes.
So then if the bigger one is always going to be A.
Yes.
So just make it, just even if it's flip flop, just flip flop it.
Yeah. A squared is always the larger denominator with ellipses. With hyperbolas, it changes. Okay? Right now, it's just whoever's the big one. Okay. Here goes. Can you complete the square?
Just once, not even twice.
Yeah, you can do it twice.
Oh wait. Oh yeah.
Mwah, ah, ah, ah. Can you write this equation? Son, you forgot to actually add to that side.
What did I do?
Uh-huh. A, you wrote those there but didn't actually change it.
Yep. Alright.
B, these are wrong.
They are.
Did you really add 25?
Nope, I didn't say that.
There you go. In fact, if we have that where the denominators are the same on both, we'll talk about that tomorrow, that's a circle.
That's what I was thinking.
The circle.
So if it's like not over something, I did something
You
wrong.
can make it over something.
The denominator can be blah 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 over 1. Y whatever over 1.
Not often I say this, listen to Logan. Because he's right.
X plus 2 squared.
So whatever A or B, whichever one it is, squared.
Group your X stuff, group your Y stuff, factor out A if you need to. Add B over 2 squared. Add B over 2 squared. Be careful whether you're actually adding that number or a multiple of that number.
That doesn't make sense. Or wait, that does make sense.
It ends up a little goofy. Your Y value will have a compound fraction because you'll have fraction on denominator. Oh, it's tiny. This thing's like a pinto bean. It ends up being only 2 units wide and 1 unit tall. Itty bitty living space.
So C in the plus 25. Yeah. It's in parentheses.
So what does the 4 do? The 4 is what.
Where we're having problems.
Yeah.
Okay.
Well, because on the last one it canceled out.
Are we getting to green?
Yes.
And then we're arguing about what happens next. Okay. If I need a denominator, but it already equals 1, couldn't I just put this over 1? Well, I can't put this over 1 because if I do, that 4 is in the wrong spot. So think about biconditional statement. Dividing by fractions is easy as pie. I flip the second and multiply. So multiplying by a fourth is the same as dividing, or by 4 is the same as dividing by 1/4.
So then would B be 1 or 0.5 of it?
Yes. It's itty bitty. This thing's tiny.
Why wouldn't you just. Can you not have a number?
No, that's not the form of the equation. That would be like if I said, hey, I need help moving. Can someone come over with their pickup truck? And you come over with your little Prius.
Oh, yeah.
And you're like, but I can strap things on the hood. No. I asked for a pickup. And if you're pulling a little go-kart trailer behind it, maybe. Even the smallest, the 5x6 trailer for a U-Haul exceeds the max tow rating for a Prius.
How do you know that just off the top of your head?
Because my buddy asked for a pickup to help him move because he has a Prius. I'm not a very original person. I just say stuff that's happened. Okay, is this thing going to stretch vertically or horizontally? Okay, 1 is bigger than 1/4. All right, well, the center. Be very careful. A squared is 1, so square root of that, A is also 1. I'm going to 1 in both directions. 1 to the right. Vertex at -1, 5. 1 to the left. Vertex at -3, 5. Be very, 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 very careful. What is B?
1.5.
Square root of 1/4 is the square root of 1 over the square root of 4. So B is 1/2. I'm going to 1/2 in this direction. 5 and 1/2, or 11 halves. I'm going to 1/2 in that direction. So 4 1/2, or 9 halves. My foci. C is square root of 1 minus 1/4. Is the square root of 3/4. Is the square root of 3 over the square root of 4. Is square root of 3 over 2. Well, what is the square root of 3 ballpark? We should remember this from seeing it on our calculator over and over and over in the last chapter. 1.41 is square root of 2. 1.729 is square root of 3. So 1.73-ish divided by 2 is about 0.86-ish. Well, if this is 1, can you go 86% of the way there? Yeah. So I'll have a focus at -2 plus square root of 3 over 2, 5. And another focus at -2 minus square root of 3 over 2, 5. Now, I have mine drawn here, and everything looks fine and dandy. -2 plus or minus C.
This is the x-axis.
Uh-huh.
You have -2x, but then you have -2x, they're side by side.
It's -2 minus.
It's -2 plus a value, -2 minus a value. There you go. Now, okay, I've got this on a big honking board, and we're like, oh, I thought that was a comma because it was really big. What happens when this thing, what was it at? -2, 1? -2, 5? -2, 5. 1, 2, 3, 4, 5. There's your ellipse. I dare you to fit everything in there. I've had students who come close. There are some kids who write really, really, really tiny. I have to go back and look through my old stuff. I know we had one kid where, like, I got really good eyesight. I had to bust out my phone and zoom in on her stuff a few times. Okay, she writes really tiny. I didn't want to have the magnifying glass because if someone came in and saw me, then I already get made fun of enough through being old. So we got just enough time. I don't want you to graph it. I just want you to complete the square.
It's large. We'll have to tell Leslie here when we see him again.
So 5 divided by 5, 16, 16, 9 is 90. 9 by 6 is 54, 144. 144 negative 44 is 140. Divided by 4 is 2, 4 is 144 is 12. 9 and 36, 4 and 36. X and 9 and 54 is...
So you get x minus 1 squared.
I might be wrong.
You are
5, 2 is 5 plus 1 minus 1. Okay, that's right. 5, 3, 9, 4 minus 4, half that 2. That's right. 5, negative 4 is over there. 9. And then that is 4. Is 4, half that 2 squared
9 times 4.
is 4.
You should get 36 on the other side. Divide by 36.
Oh, I did not do b over 2 when I completed the square with the y. I just did b.
You had a tough house.
I know. Because that's 4, half that's 2. 2 squared is 4 is 36. 36, 32, 4 is 36. 36, 9 is 9, and
There you go.
I didn't do over 2 when I completed my square. At least with the y term I didn't, because then I ended up with 144 again. Womp womp. Okay, so we'll start there tomorrow. Tomorrow I'm not doing a daily quiz because it's a shortened class. Come in, notes out, get going. Okay? We're going to do this. Just foot on the gas, finish off 7.2, try to get into 7.3. So that 7.3, I can get you as much of it as possible. Quiz on Friday.